Hello everyone, today in this video we'll be discussing the important questions from module 4. So the module 4 is mainly regarding some algorithms, okay, and some theory parts, okay, and along with that there are some numericals as well, okay, that I'll be discussing in a separate video, the numericals, and in depth about the algorithms also we'll be discussing in a separate video. In this video I'll be just touching on the theory concepts regarding the formulas what you need to keep in mind and the algorithms what you need to keep in mind. So if you watch this video, this should be more than sufficient for you to score well marks in this from this module, okay. So before this the 3 videos are made, make sure you watch those 3 videos first, then you watch this video, okay, because in that order if you do it will be more better for your understanding. So let's get started, and let me tell you there are 4 important topics from this module, okay. How many topics are important from this module? There are 4 important topics. The first one is the definition and the general approach of classification. What do you mean by classification? The definition part of it, and then there are different types of classification. After you have given the definition of classification, you can give an example as well. All these points I'll tell you what you need to keep in mind. Then we have to write the different types of classification, okay. After that there is a general procedure of classification and you have to draw a neat diagram. After you have written these 2 things, then you have to give the general procedure of classification. See, to do something there will be a procedure, right? So to classify the things also there is a procedure, that is known as the general procedure. There are different types of classifier like rule based classifier, Bayesian classifier, Naïve based classifier, and many others are there, okay. But all these different procedures have something in common, okay. That what is in common, that is the general procedure. That general procedure will be discussing with the example as well as a neat diagram, okay. So if you like this video, hit the like button and don't forget to subscribe to my channel. Your support helps me make more videos like this, so don't forget to like this video and subscribe to my channel. Fine. So let's get started with the first question, definition and general approach of classification. After that the important ones are decision tree induction, there is an algorithm as well as example, rule based classifier, and the last one is nearest neighbor classifier, okay. But this one is also coming under that only, the Bayesian classifier. So and this one is from the module 3 topic, so it's included by mistake here. So all you need to focus upon is you need to know what is classification and the general approach of classification. Then you need to know 3 things: the decision tree induction algorithm and example, rule based classifier, and the last one is nearest neighbor classifier. After that the Bayesian classifier is very simple if you understand this one easily, okay. So let's get started with the first question. What is definition and classification? The notes, this PDF can be found in the super important PDF, means the folder in the link 6SEM PDFs in the description box you can find, and the notes which I am referring, that can be found in the same link 6SEM. In that there is a folder called as 18 CS 641. In that you can find these notes as well. So what you have to do is come to page number 71 and there will be finding the answer. What is classification? First understand what is classification. If you have 1000 things here, you are separating those things based on its similarities and dissimilarities. That is what is classification. The things like classification, clustering and all are same, but just slightly differences are there, okay. That slight differences will be learning in depth in each module. That's all what is there in the data mining whole subject, right? So what is classification? The definition, the first point what you have to write: classification is the task of learning a target function y, target function f, that maps each attribute set x to one predefined class label y. X, it matches means it maps to y and it is defined as a function. F of x is defined as x that maps to y, that is called as the classification. What is classification? It is a mapping, okay. What is classification? It is a mapping. Mapping of what? One set x to another set y. Mapping of what? One set x to another set y using a function. That's all what is classification. And you have to draw this diagram. Input attribute set x, there will be an input attribute set which is known as x attribute, and here you will have the output class label y. Here the classification will be done and then the output level will be taken as y, okay. So this model is known as classification model. So 2 points you got here. The first point, the definition part, it's a function which maps to x to y, and here's the diagram as well. So these 2 things you have to mark in the first point, the definition of classification. What was the next question which was asked to us? The next question was different types of classification. What do you mean by different types of classification? There are mainly how many types? 2 types of classification are there: descriptive modeling and predictive modeling, okay. 2 types: descriptive modeling and predictive modeling. By the name itself you can understand what is descriptive. Descriptive means detailed or explanatory tool. Here you will have many features and you will have much more data. In detailed you will have the data, By using the detailed data, you will be classifying. What is descriptive modeling? By using detailed explanatory data, you will be classifying the things. So here, for example, what is given is the name is given human, python, frog and whale, and the different parameters are given like body color, skin color, gives birth, aquatic creature, aerial creature, has legs and class label. So based on that, the values are also given, what are the corresponding values for each of these terms and what is the class label for that. If these values are present in something, that is mammal. If these values are present, it is reptile. If these values are present, it is amphibian, and here again it's mammal. By using the descriptive analysis, you will be writing the answers here, that is known as descriptive modeling. Now by using the previous data, which is known as, this one is the previous data, right? By using this data, if you predict a new species, okay, there is a new species and that new species has these features for the given data set here, and can you predict what it is? Based on the previous data, easily you can predict it what it is. This is the second type of classification called as predictive modeling. You'll have the data, using that data you will be predicting, that is called as predictive modeling. And this is a descriptive modeling. Here you will have much more data as compared to predictive modeling, and this thing will also be given to you. You are not finding anything here, you are just analyzing here. Explanatory tool for your learning purpose, and this is for predicting ones. Okay, that is the difference between descriptive modeling and predictive modeling. That's the second question's answer, different types of classification. Then we have explained the general procedure of classification with a neat diagram. First let's see what is the procedure, then let's see the diagram related to that as well. So what is the general approach to solving a classification problem? The general approach is that there are many other algorithms, okay, like decision tree based classifier, rule based classifier, random forest classifier. There are many other algorithms, okay. All these algorithms have in common that is called as the learning model. There is a learning algorithm in all of these that is common to them, okay. That's the first point what you need to write. The general approach is that there are many algorithms, and in that many algorithms there is a common feature in all of them, that is called as learning algorithm. In learning algorithm, what happens is you will be able to identify the best method to do a task. In learning algorithm, what happens, you will be able to identify a best way to do a task. For example, here's a large set of apples are there, okay. So if a large set of apples are there and some kids are there, okay, you want to give the apples to many kids here, okay. So instead of just taking one apple and giving to this kid, second apple to this kid, third apple to this kid, what you can do is count whole how many apples are there, then divide by the number of kids and give them that many apples at a time. That will be more better way and efficient way, right? So that's what we are doing here. By using the learning algorithm, which is common in all of the algorithms, we will be finding out the best way in which you can distribute the things. You will be finding the best way in which you can perform the task, distribute the things, or whatever you call it, okay. So that is called as learning algorithm and its application. That's the second point you need to write. The third point is you need to make this diagram. In this diagram you can find three things, okay. Let's divide into three things, and the flow goes like this in a anti-clockwise clockwise direction. The flow goes in which direction? Clockwise direction, okay. So what is the first thing you can see here? The first thing you can see here is what? Table. This is a table which is called as input set, also known as training set. Here some data you have like the IDs and the attribute and the class values, and this goes to the learning model. Learning model is like a machine. There the input will go and you will be performing the learning algorithm on it. What it will do is, based on the given data and based on the given learning algorithm, based on what? The given data and the learning algorithm, it will form another model. That model is based on the particular context. Based on what? A particular context. A particular context means for if I say you like an example, this is for the reptiles, or this is for the animals, this is for the birds. For that specific context of application, it will be defined. A specific model will be defined using what two things? Input data and learning algorithm. When this model is defined and another situation comes where you have new data, so what you will do, for each of the new data you will be selecting a specific model which is already with you. You will be selecting that specific model and applying the model and then deducing the class of it. Class means the output. If a new animal comes, you will be seeing what are the attributes of that animal, or it might be a bird also, or it might be a reptile. So based on the attributes you will identify if it is an animal or the bird or the reptile. To quickly recap what you did, input set is here, you did a learning model, and based on the learning model you applied a learning algorithm, and then you formed different types of model for different context. And based on those models, when you get a new value, you will be identifying which class it belongs to, okay, and based on that particular model. That is what you need to describe when they ask you about the classification with means general procedure of classification with a neat diagram. The next important concept is a decision tree algorithm with an example. What is decision tree construction procedure with an example? We have to explain in a stepwise manner and write and explain the algorithm. Firstly, we have to know what is decision tree induction algorithm. First, let's understand this algorithm, and then we will see the example, and then we'll see how to write it in stepwise. Decision tree, before going to the algorithm, the first point what you need to write is, it is a classification technique, widely used classification technique, and it has how many things? 3 things. That's the second point. Root node, internal node, or the leaf node. What do you mean by the root node? From the root node only the different nodes arise, right? And if I give you a visual representation, this is called as root node, and this is the internal node, and this is what? The leaf node. This is what? Root node, and this is what? Internal node, and this is what? The leaf nodes. So different types of nodes are there, and the definition is given as follows. Root node is that which has no incoming edge and 0 or more outgoing edge. So only from the root node the outgoing edges will be there, or it might not be there also. Internal node means it has both the outgoing as well as incoming edges. In the leaf or the terminal there will be no outgoing edge, but there will be an incoming edge. Fine. So that's what the different parameters you got 2 points here. The first point you'll write, it is a widely accepted classification technique, decision tree induction, and there are 3 things: root node, internal node, and leaf node. Okay. And if they ask you about the stepwise algorithm and giving an example, the example what you can give is this one. There is a body temperature here. The body temperature can be what? 2 types. 2 types of body temperature, what? Warm and cold. If it is cold, it is non-mammal. If it is warm, then we cannot still say it is a mammal only. It might be a non-mammal, it might be a mammal. Okay. How that classification is done, whether it gives birth or it does not give birth. If it gives birth, it is a mammal. If it does not give birth, it is a non-mammal. Now can you tell me what are the root nodes present here? Internal nodes and the leaf nodes. Root node, internal nodes, sorry, this is not internal, this is leaf node, leaf node, leaf node. Okay, this is the example you need to write down. Now let's discuss what is the algorithm, and algorithm in brief I'll discuss in detail in a separate video, as well as the numericals I'll discuss in a separate video. For now I'll just let's briefly go through the decision tree induction algorithm, how it works, how to build the decision tree algorithm. Okay, so to build the decision tree algorithm we will be using Hunt's algorithm. Hunt's algorithm is same as decision tree algorithm, just a different name is there. So you will have a different set of training records. Why is a set of training records? There are many records are there. Okay, means data is present, a lot of data is present in set Y. Fine. And if all the record belongs to the same class, then the leaf node becomes the same class. Repeat with me. If all the data belongs to the same class, the leaf node becomes the same class. That's all. The second one is, if all the data belongs to more than one class, then what happens? If data belongs to one or more class, different classes, how do we choose which class we need to choose? We will choose that class which it is closest to, which this is closest to that class we will be choosing. That's the second step. So even if you did not got, don't worry, I'll explain these things in a separate video. There I'll be going in depth and hopefully clearing your doubts. Okay. So if I give you a brief overview of what this example is, there is a ID here: homeowner, marital status, annual income, and defaulted borrower. Okay, so we are just trying to means classify if the person will be able to repay the loan or not repay the loan. So you have to draw here how many diagrams? 4 diagrams you have to draw. The first diagram is defaulted, it will be no. Then you will consider one attribute which is homeowner, whether he is a homeowner or he is not a homeowner. If he is a homeowner, defaulted will be no. If he is not a homeowner, then defaulted will be no. The next one, the second parameter is marital status. We will consider marital status. He is a homeowner, yes, then defaulted no. If it is no, then there is another parameters coming. Whenever there is no, then only parameter will come. Marital status, single, divorced, yes, married, no. Then the next one is this one, another parameter for no marital status, for here married and single, divorced. Single, divorced, annual income, if it is less than 80k, greater than 80k, it is no. If it is less than 80k, it will be yes. Okay. So that's what it's given here. I will be discussing this in a separate video. So for now, let's go to the next topic. Okay. So that was about the decision tree algorithm, and here you will be using 2 things, which is the attribute testing values and the splitting stopping condition. So these things I'll discuss in detail in a separate video. Okay. So that's all for now, and let's move on to the rule based classifier. What is the rule based classifier that we'll be discussing? And rule based classifier means there will be some rules defined. Okay, by the name itself you can understand rule based classifier. It is based on what? It's based on a rule that the classification is happening. So based on the rule, if the classification is happening, that is called as rule based classifier. Here different rules are defined, and using those rules what you will be doing, classifying. So let's have a look about how those classification is done. So coming to page number 82, you will find out the answer for the rule based classifier. The first thing what you need to write is the rules for the model are represented in a disjunctive normal form. Which form? Disjunctive normal form. What do you mean by disjunctive normal form? R is equal to R1 or R2 or R3 till Rk. That is disjunctive normal form. That's the first thing. Second thing, can give an example. Some rules you can define R1, R2, R3, R4. In that you can to the AND operation gives birth no, and it's an aerial creature. If these both are coming together, it is called as a bird. If it is giving birth no, an aquatic creature yes, then it is fish. If it is giving birth yes, body temperature warm, it is mammal. If it is gives birth no, an aerial creature no, it is a reptile. Okay, so like that you can define a sample rules like 3 or 4 rules. That's your second point. After you have defined these rules, how do you use these rules to classify the things? How do you use these rules to classify the things? That's the next thing. So how do you use these rules is, firstly you will be defining those conditions, as if these conditions are true, then only you will be classifying it as something. Okay, so how you will be using that is, you will be using two qualities to measure the answer: coverage and accuracy. Coverage means A by D. What is A? It is a fraction of the records in the D that trigger the rule R. It is a fraction of records in D that trigger the rule R. Okay, for now just keep in mind, I will discuss this in a separate video, so don't worry about that. Accuracy is defined as the fraction of records triggered by R whose class levels are equal to Y. Class levels are equal to Y and the rules are triggered by R. Okay, that's what the accuracy is. By using the accuracy and the coverage, by using these two, we will be making use of rule based classifier. We will be doing the classification things. Okay, so here's an example. That's the third point you have to write. In this example, there are some things given here. These are the rules given. Now to us, what is given is another thing is given, like it's given just body temperature cold. Is it non-mammal? We will be specifying. If it is warm and gives birth, we will be checking the table and seeing if it is mammal. If it is warm and gives birth, no, it's non-mammal. Like that we are trying to identify the things. That's what it is, the rule based classifier. By using the rules, you are seeing the new data and classifying where it belongs to. Okay, so here's a detailed algorithm as well. So this will be discussing in a separate video. So for now it is this much only. Let's move on to the next one, which is nearest neighbor classifier. Okay, nearest neighbor classifier, and in nearest neighbor classifier, by the name itself you can understand what does nearest neighbor classifier mean. Nearest neighbor classifier means whatever is near to each other, that will form a group. What will be far to each other, that will be forming a group. That's all. Okay, the first point you need to write is the classification framework involves a two-step process: inductive step and what? Deductive step. Inductive step and what? Deductive step. In inductive step, you construct a classification model. In deductive step, you apply the model to test examples. You construct a model, you apply the model. That's all. Construct and apply. Construct and apply. That's all what you need to keep in mind. Construct and apply. Okay. Then you have a few types of learners, like the eager learner, lazy learner, and rote classifier. So these two can be eager learner, and the lazy learner can be nearest neighbor. Rote classifier, an example of lazy learner is the rote classifier, which memorizes the entire training data set and then does the classification. Okay, so those are different types of data sets. And the next means the sub question what they are asked is 1, 2, 3 nearest neighbor. The characteristics I just explained the different types of learners. 1, 2, 3 nearest neighbor. 1, 2, 3 nearest neighbor means 1 nearest neighbor means 1 will be captured. 2 nearest neighbors, 2 will be captured. 3 nearest neighbors, 3 will be captured. Okay, those are the 1, 2, and 3 neighbors classifier. And algorithm is also given here. 6 steps process is very easy. You are just calculating the distance between the points which are nearest in distance. Take it as one group. Okay, take it as what? One group. So this one I will discuss in depth in the separate video, and there are formulas as well. So each of those things I will be discussing. So a detailed explanation regarding the characteristics is given here. What is the basis of learning, the model of learning, and information, high variability. These are the different characteristics. Okay, so if you go through it once, what does a lazy learner do, how do they predict the values, those things can be found here. Okay, The next one we have the Bayesian classifier or the Bayes theorem or Naïve Bayes theorem. Okay, it is the most important question in the which is present in every data mining previous year papers. Here you have to do three things: define Bayesian classification, explain Bayes theorem using conditional probability formulas with example. Okay, so let's see. This is the Bayesian classifier. In Bayesian classifier, you will have two things, x and y. For x, one probability will be there. For y, there will be one probability, and these probabilities form a formula called as Bayesian formula. Okay, x and y will have one probability. Using those probabilities, we will be forming a formula called as Bayesian formula, and this theorem is called as Bayesian theorem. That's the first key point you need to write. Then you need to write for each p of x and y refers to the probability of the variable x on x, y on y. This is the second key point. The third key point is this formula you need to write. P of x by y is equal to y by x into x, x by y into x. X by y into y. Okay. So this formula is called the Bayes theorem, and this can be simplified and wrote here. That's the third key point. And it can be used for the classification as well by using the formula directly can classify. Here's an example also given. This one I will be explaining in the algorithm and the numerical video. And the application of the Bayesian classifier is the Naïve Bayes classifier. Here also just the same thing. The first key point what you need to, if they ask this, is estimate the class conditional probability by assuming that the attributes are conditionally independent. This is the key point. Conditionally what? Independent. If they are conditionally independent, then only you will use this one. If they are conditionally dependent, you will use the Bayes theorem. And this is the second key point. You need to write the formula and explain each attribute. X belongs to the constituent of D attributes. Okay. And what is conditional independence? Each of these will be disjoint. Each of these will be disjoint. That is known as conditional independence. X by y tends to z is equal to x by z. In characteristic also given, it is robust, it is taking less efficiency, means the less time and more efficient, and the attributes are conditionally independent, so it is more easy to perform the operation upon. And after that there is a subtopic Bayesian belief network, so that is not that important. So for now this is this much only I will discuss. Then the last one, which is methods for comparing classifier, different methods with the formulas. Come to page number 80, then there you will find the methods for comparing the classifier. Since it is not that important, I will just discuss very briefly. Estimating a confidence interval from accuracy. How do you, if confidence is given to you parameter, how do you determine how accurate it is? Okay, by using two things, success and failure. By using two things, success and failure, and by using the binomial expression. So this is the expression which you will use for calculating the accuracy given the confidence value. That's the first thing. Comparing the performance of two models. Here you will be using this formula, which is the variance formula. Comparing the performance of two classifier. Here you will be using the formula which is k equals as partition formula. K equals as partition formula. Okay, these three things are there. These formulas you have to write and write few words regarding each of these. Okay, so if you have any doubt, ping me on Instagram. My ID is in the description box. If I have time, I will reply to you. And make sure you hit the like button and subscribe to my channel. That helps me make more videos like this. And thank you so much for watching. I will see you in the next one.